What can I say about AI that you probably haven't heard before? Like, that's a tall order. Everyone likes talking about AI. A lot of people like saying things about what's the best AI tech, where AI is going, what are the best problems to solve with which tech. A lot of talk about that, but not so much talk about people's personal journeys about going through AI. Like, have you thought about and reflected on your journey about going through AI and how your perceptions of AI have changed? Now, I'm not talking about just lately with the large language models. I'm talking about before that. And I mean way before that. I'm a computer engineer. I graduated as a computer engineer. I moved more into business engineering now, but still I am at the core an engineer. And there are reasons why I'm an engineer. There are a lot of people like me who became engineers and then worked their way into AI. I became an engineer because I loved AI and decided later, after playing around with AI, that I should be an engineer. So my perspective is a little bit differently than a lot of the people that I work with, because I sort of did it backwards. I played around with AI as a kid and then decided to choose it as a possible solution for the things that I'll be doing during my career. Now, I got into AI, not directly though. It wasn't just that I picked up a book on AI and thought, oh cool, it's AI, let's start building some AI. I got into AI because I saw the movie TRON. This was in the early 80s. And I was a young guy, like a really, really young, I think 10 or something like that. And I saw TRON. I saw the light cycles in TRON and how blue light cycles would try to wipe out red light cycles. And as a little project, I decided to program the light cycles video game using BASIC on a computer called an Atom ColecoVision. Like before I never made video games. I played around with the computer, making little dancing men, little sprites dancing around, little animations, maybe some music and things like that, like the musical keyboard type stuff, but never a video game. I never went off the trail and made my own video game. And that was pretty new for me. And I got the light cycles game to work. Collision was a little bit interesting in terms of the logic. I realized priority of code does affect gameplay, but after getting that to work, I was quite happy, though I was quite tired too. At the time when I was doing this, it wasn't a thing to learn to type until you hit high school, right? And I clearly was not high school, and so a lot of my frustration with programming and making video games was primarily because I was such a slow typist. Really, really slow. But that didn't stop me from making games. I just kept on at it. And after making a few different types of games, things like something similar to Missile Commander and things similar to ships falling and navigating through caverns because they're being pulled down by gravity, I created a game called Dagger. Now, that just reflects how uncreative I was when I was a kid, because all it was about a hero who had a magic dagger and zombies would pop out of the ground. You would throw the dagger at the zombie and the dagger would eliminate the zombie and fall to the ground where the zombie was eliminated. And that was pretty much the game. You run to get the dagger before the next zombie gets you. And you kept on running around on the game screen to avoid the zombies. Now, the zombies were dumb. There was barriers all over the place, and if you knew how those zombies worked, you could easily make it so that they are locked on a certain wall or in a certain way. So it did not make the game that fun once you figured that out. So that's really what sparked my interest in AI, is I wanted those zombies to be smarter. I wanted the game to be more fun. It was sort of a puzzle, and I liked puzzles when I was that age. I solved the Rubik's Cube. did the Rubik's Magic thing too. All puzzles were pretty easy for me. Don't know what I was thinking of or how I was then, because I sure the heck can't do any of that now. And it was so this was just another puzzle, and it brought me to the library. Now, the town I was in, this was the early 80s, under 25,000 people. There's not much selection on AI in such a small town. Even when I was to request books from the larger city, the capital of our province, to get the books into my small town, there wasn't that much selection on AI either. It was primarily a lot of the books that I really needed were at the universities, and there was an easy way to get them, especially because that I was still in grade school doing this stuff. But I found one book, a 50-page book, very soft cover, that talked about game trees and how to use game trees, pruning, the number of levels, how to deal with the weights of the tree, and how to optimize them. And I used that book and used it as a guide to build an AI for my zombies to make them a little more smarter, where the game tree was really would reflect sort of the strategies that will allow the zombies to zigzag or to sort of sneak attack you, or wait and see type thing. And I used some random numbers generation to make it so that the zombies were a little more unpredictable. And that made the game a heck of a lot more fun. But what I remember is that typing so long with just 2 fingers was so tiring. And it was exhausting to do. But that didn't stop me from making the games. It was really exciting to do. And I kept up with the AI, trying to learn as much about it, but ran out of resources. But all the AI books talked about psychology. And so I read up about psychology and checked to see how that could be applied to AI, like things involving chunking, keeping information close, algorithms, the idea of algorithms, having stable algorithms and repeating the algorithms over and over again until you get the right solution. That idea came from psychology. I did not get that idea from computer science. It was reintroduced to me under the umbrella of computer science, but I learned it originally from psychology. So I have a strong passion for psychology and how it's married to AI and how both of them influence each other. And this really reflects to how I see AI being used today and how psychology influences its design and its use. And that's where my passion is really that interface between the two. Because that's, I think, really where the meat of the issues are. If you perceive the AI is doing a good job, well, the AI is doing a good job. Now, when I was really deep in AI, I was really excited to go to university and learn more about AI. And I had the choice between engineering to computer science. Now, engineering focused on things like constraints, impediments, options, trade-offs that you had to do for performance. Computer science, now this was at the time, and this was like in the 80s, it was unlimited processing power, unlimited disk space, unlimited memory, right? Which I didn't agree with any of them after making those games as it was when I was a kid. So I gladly went into engineering and not computer science. And because I took engineering, I had the option to take psychology courses. But I was really disappointed that I couldn't. You see, with my program, I could pick psychology or economics. The problem is, because I wanted to focus on computer engineering, I could not get access to psychology courses because the time slots, they all were conflicting time slots. And these psychology courses weren't being offered during the summer either. So they were pretty hard for me to take. So I got stuck with economics. And economics, I never realized it was psychology at the time. All I really remember was that disappointment. It's not until later when I started using some of the ideas and the principles of economics and using that for data analysis and data science did I realize, well, yeah, it is a form of psychology. So I'm not disappointed now, but I sure remember it back then. Now, once I finally got into doing my AI courses later on, it was on a general AI course. It focused on languages at the time, like Prolog and Lisp, but also things like expert systems, neural nets, and all these other different flavors of AI. And my big takeaway from that was with really playing all the different technologies. Like AI is really good at getting the approximate answer, but if you spend too much time trying to optimize it or trying to train it, that you can get some really weird results. And I remember seeing that, like too much training killed the results. I also found too, especially when dealing with projects involving Prolog, with the medical, I wanted to do a medical diagnosis of a patient who is either overworked or dying from a serious illness. Right? Well, there were a few other conditions in there, but really the way the knowledge was being represented and set up, and the way that you like base certain relationships, if they were put in the wrong order or knowledge in the wrong place. Someone with a fever, could be, there's serious illness and they could die, which really is not necessarily the case. So I got really weird results when doing that. So I had to add more relationships, more weights, more counterweights to make sure that the results would come. So something I thought that was a simple premise of maybe 2 pages of code turned into about 50 pages of code. Oh, the TA was rather not too happy when he saw what I gave them for him to scan through for my grading. But it was something, a learning experience to me, because there's a lot of extra work that you need to do to get AI to work right. And the only way you know that is from experimentation, because there are these contradictions in terms of it, like it's either one or the other. It can't be both at the same time simultaneously and then change later. Like AI is, you need to have all the right pieces for AI to do the correct classification of something. And if you have too much noise in it, it can really mess around with the classification, the correct identification of something. And I've seen this even now today with such stuff. If you don't have direct control over what's being input into the AI, then you really can have unpredictable results. The best way to use an AI solution is make sure you have strong guardrails on it so that you have the input controlled, because then the AI becomes very accurate and very useful. Like for instance, if you are assuming that everyone's filing auto claims in Canada, and the AI assumes that, then it won't get messed up if you try to file an auto claim that's from Britain or something like that. And that's just really a basic example. AI does have its limits, and that was really drilled into me when dealing with a general AI course. But with the AI, I was also taking algorithm courses too, and this was things on security, encryption, and way back then. This is like the late 80s, early 90s. And just remembering all those stuff and all those algorithms. And one algorithm in particular that I'll never forget is what's the name of it? I don't remember the name, but I remember the initials, where it's SE, because I use SE quite a bit for curve fitting and things like that in the past. And it was where you used it to navigate through different obstacles to make sure you have an optimal path. So if you want to deal with things involving logistics or communications or transport, things like that. And the professor wanted sort of examples and such. And so since I was running my simulations and running the algorithm on a Spark computer, a Sun Solaris Spark computer, which happened to be named Spock, I said, well, how about we have the Star Trek Enterprise navigate through an asteroid belt? And so that was my presentation to the class. Oh, class loved it. Professor didn't, but I still got a decent grade on it. But it was just something where the idea of where you're able to run an algorithm and you run it enough time with enough processing power, you'll eventually get the right answer. It's just that the accuracy is really relevant to the amount of time and processing required, which was something where I've always considered something very foundational in terms of AI. If you're always doing the same thing, and it'll always lead you down to the right path if you keep on repeating doing the same thing, and that's a strong cornerstone for AI, if it's repeatable. And that's really my takeaway in terms of it. Now, after going through those AI courses and those algorithm courses, I finally had the option of getting my thesis topic. And I picked the AI thesis topic. It was the only one, so I picked it. And that was on syntactic pattern recognition. And syntactic pattern recognition is where you look at something, an object, a thing. You determine what that thing is made up of, its primitives. You break it down and determine how the relationships are between the primitives to recognize the object or the thing. This is similar algorithms are used, or similar approaches are used in sentiment analysis, things involving large language models, things involving cameras and understanding imagery and things like that. So it's there's variants of it still being used today. And that makes me smile. I did not like that thesis so much. I was happy it was AI, but I really struggled through it because as a thesis, I had some simple things to have to prove. How could my AI recognize waveforms, right, for digital signal processing? How could I have it recognize waveforms? Like something simple. So how could I tell the difference between a square waveform, a sine waveform, and a triangle waveform? Now, what I learned is that you really got to constrain the input to your AI, because if I jacked up the amplitude and increased the frequency or decreased it, I could convince my AI that whatever I was giving was what I wanted it to be. So I could turn a square waveform into a triangle. I could also do the same with a sine. I could convert my triangle into a square waveform. And the AI really couldn't tell the difference. So really, need major guardrails in terms of your input for AI. It's for the AI to be accurate, because if you don't, you're going to get some garbage. And we really, really don't know that. We really don't want to have that. Now, so really my takeaways as a kid is that with AI, you focus on what's good enough in terms of your approximations, get the approximate solution, then add on to that solution. That makes the most sense. So if you use AI today for that sort of thing, to approximate and then add your special sauce or your adjustments, that's pretty good. Also, too, with AI, you restrict your input to avoid the contradictions or the problems that you have with AI, that the AI can spit out, because then you can focus on a less complex AI and a more accurate AI. So controlling the having those guardrails, making sure that the AI doesn't go completely off track. And that's the other lesson learned. And there are other lessons too that I've learned about AI, but that's more going to be for a later video when I talk about what sort of things I've seen when I started working in the AI field, when people thought AI was too academic and just a toy.